for you to prepare for the exam. Okay, so let's go to the multiple regression. Fine. See, so in the multiple regression, what you have to understand, what is the trivariate data, then use notations are there, then fitting of multiple regression planes, then partial regression, partial regression coefficient, multiple correlations, and all these things are there in the syllabus. We are going to apply shortcuts and we will understand the important concepts only. Okay. So first I will tell you what is the need of multiple regression. Okay. So with the help of the examples. Am I audible to all of you? Yes.
Yes, sir.
Okay. Okay. What is the need of multiple regression? Now, simple regression means, what is simple regression? Simple regression means studying the two variables at a time, right? Means regression between the two variables. Simple regression. Now, many times we observe that two variables are not sufficient. We need more number of variables, at least three. Okay. So first we have to understand the trivariate data. In your syllabus, your multiple regression topic is restricted to three variables only. Okay. And when we collect the data on three variables under study, so these are such a data is called as the trivariate data. Okay. So these are some examples where we can use at least we need three variables. For example, suppose you have to determine the height of son or daughter. So minimum you need the height of father and height of mother. Okay. So two variables are not sufficient. You cannot determine the height of son or daughter on the basis of father or mother. You want both at least. Even though you can include many variables like height of your grandparent, height of your grandfather, height of your grandmother. You can also include the maternal and paternal, okay, relationship. But at least you need the three variables. Okay. So height of son or daughter is to be determined, then at least you need the height of father and height of mother. So here we use the multiple regression. Then blood pressure. Everybody knows that blood pressure depends upon the age and the weight of a person. You cannot determine the blood pressure on the basis of only weight, okay, or on the basis of only age. You need all the three variables. Minimum these variables will be there. So here we use the multiple regression. Then monthly rent, location from the central place, and area in square feet. These are what depend. Now, what will be the rent? It will depend upon at least two factors. Location from the central place means how far it is from the central place. In our now this is our MIT college. So if somebody is residing nearby MIT, then he or she has to pay more rent. If somebody is residing a few kilometers away from the college, then they have to pay the less rent. Okay. And second factor, area in square feet. I mean how big that room or that flat is. So at least these two variables are required. Then marks, IQ, and hours of study. So how much marks a student get? It will depend upon IQ and hours of study, not only just on IQ. IQ means intelligence. Okay. However, maybe the student कितना भी intelligent हो, but वो पढ़ाई नहीं करेगा तो marks उसको नहीं मिलने वाले. Okay, so marks will depend upon IQ and hours of study. So both the things are there. Okay, you just studying and you are not understanding, then that is also useless. And you are understanding, but you are not giving time for practice in study. So that is also not useful. So at least you need three variables. Okay, so all of you understand what is the need of multiple regression. So please blow your thumbs. Okay, so let's go ahead. Now I will explain you the some terms in that. What does a trivariate data look like? Are you clearly able to listen my voice?
Yes, sir.
Okay. Trivariate data. What is a trivariate data? You have three variables, x1, capital X1, x2, x3. So you have a triplet of data, okay? And you collect the observations on it. means observations are written by small letters, right? So small x11, small x12, okay, and so on, small x1 n. Then observations on the second variable, right? 21, x22, and x2n. Similarly, x31, x32, and similarly x3n. So this is a trivariate data form, okay? And you will observe that it is nothing but a triplet. And what is this? This is the information about the first family. Suppose it is the height of son, father, and mother. So this is from first family. Height of son, father, and mother in first family. Then this is for second family. So now it is for nth family. Okay. So this is the way of writing the trivariate data. So what we observe, it is a triplet. It is a triplet. These three values are there. So triplet of observations. Okay. So now you have to understand the correlation matrix. Okay. Because here there are matrices. In simple correlation, in simple regression, there was only one correlation. Either you call it RXY or RY. It is the one and only one, that is correlation. Okay. So, but here uh, there are a number of correlations exist here. So let me explain you with this. So correlation matrix. We define the correlation matrix for that. These terms you have to understand very carefully, because without this you cannot attain the numericals. Okay. So correlation matrix, let's try to understand. Now there are three variables, right? X1, X2, and X3. Here X1, X2, and X3. How many correlations are possible? Total 9. Okay. How? It is R11 correlation between X1 and X2. First of all, you understand that 1 represents X1, 2 represents X2, 3 represents X3. Okay. So without until and unless told, you have to take this. Now R12 means correlation between X1 and X2. Okay, in this way, X1 and X2. Similarly, this is R21, R22, and R23. Similarly, this is R31 means correlation between X3 and X1. Correlation between X3 and X2. Correlation between X3 and X3. Okay, understood? Now we observe that the correlations at the diagonal are the correlations between the same variable, isn't it? So that will, the correlation between the same variable will be exactly 1. Okay. And another observation we have, now correlation between R12 is nothing but the correlation between X1, X1. How? What is this? This is, what will be the formula of this if you have to write it? So this is nothing but the correlation between X1 and X2. How you write the formula? How you write the formula here? It is nothing but, how you write the formula? X1, X2 upon n minus X1 bar into X2 bar. And what happen if you write 2, 1? So it will be Rx2 X1 upon n minus X2 bar into X1 bar. Does it make any sense? Are these different? No. R12 is equals to R21 because this is simple correlation. Okay. So first you have to understand this. Similarly, R R13 is equals to R31, and simple correlation between X2, X3 is equals to simple correlation between X3 and X2. Okay. So looking at all these points, means these 2 points, finally the correlation matrix reduces to this format. Understand this one? This is diagonal elements are 1. Okay. And now you have to mention only this one, R12 here, R13 here, and here R23 there. Okay. So you have to form the correlation matrix, you have to understand only these 3 correlations, simple correlations, R12, R13, R23. Now, how to write this? So R12 you have to write just opposite to it here, then R13 again opposite to it diagonally, and here R23 here. So very simple to understand. Did you understand how to create the correlation matrix? Yes. Those who understand, please blow your thumbs. This is the very first thing you have to understand. Okay. Very good. Now this is the correlation matrix. Okay. Now next you have to understand the cofactors. Okay. Cofactors. How to find out the cofactors? Minus 1 to the power I plus j and minor of Rij. Minor of Rij. Okay. So now cofactors जैसे कि simple correlation हम R12 is equal to R21 कह सकते हैं, but cofactors are different. Okay. सारे cofactors, all cofactors are different. You have to understand all cofactors. All cofactors are different. Okay, and it is denoted by Rij. Means in a trivariate data there are 9 cofactors. There are 9 cofactors. Okay, so which are those? So these are R11, R12, R13. This is not the way of writing. I am just mentioning. This is not in the matrix form. Not in the matrix form, right? Okay. So then cofactor R21, R22, and R23. Finally, R31, R32, and R33. All these 9 cofactors are different. You have to understand it. Okay. Now, secondly, how to find the cofactor? What to do? Okay. So you have to understand this first. So let's find out anyone R11. So what do you mean by this? How you get the minor of Rij? Delete ith row. You get it by deleting ith row, jth column. Ith row and jth column. So when you delete ith row and jth column, you will get the minor in the determinant form. Okay. So R11. So R11, how you get? Minus 1 to the power. Now I is 1, j is 1. First row, first column. Now minor of Rij. Now you have to decide here what to write. So see, when you delete you have to get the minor of Rij, you have to delete the first one, first column. So this is the first row and this is the first column. What remains? So I have to write it here. Okay. What is remaining here? 1, R23. This is R23, 1. So what will be your equation? Now minus 1 to the power, square means plus sign will be there. So it is 1 minus R23 square. Okay, so this is R11. Now similarly you can get R23. I'm taking randomly. So what is this? Minus 1 to the power 2 plus 3 and minor of Rij you have to calculate. Okay, so for this you need to delete second row, third column. Okay, delete the second row, third column. So this is the second row and third column. So what is remaining? Write that. So it is 1 R12, R13, R23. So did you all understanding this? So now minus 1 to the power 5, odd power. So it will return the minus sign. And here cross multiplication R23 minus R12 into R13, right? So it will be like this. So it is minus R23 minus R12 R13. Okay. So understand this one. Everybody understand how to find the cofactors. Similarly, you can find all the cofactors. You will find all the cofactors. Did you all understand? Below your thumbs. This is very important. When you directly calculate the when you solve the multiple regression problem, you need this. Okay. So this is about the cofactor. Now, so next before we go, I will explain you the multiple regression equations. Okay. So in this, I will explain you the way how to remember the multiple regression equations. Okay. So I will not go into detail. I will explain you from the point of view of exam. Okay, is it fine? Yes or no? Okay. Now, exam point of view, I am telling you. Now, multiple regression equations. Since we are dealing with the trivariate data, there will be three variables, x1, x2, x3. Okay, so there will be three equations. Three. There will be three multiple regression equations. Understand this. Now, there are two cases. There are two cases. Case one. Okay. So I'm not. I will explain you in a very different way. Okay. In the way which you will understand better, and you will be able to solve the numericals easily. Now, in the case one, you are given the 9 values. First, you observe in the question what is given in the data. If you are given the 9 values like x1 bar given, x2 bar given, x3 bar given, then standard deviation 1, 2, 3, all the three standard deviation, then simple correlations R12, R13, and R23. So these three 9 values are given. Then you understand that you have to apply some equation. So that equation, I write the general formula. I have also, now there are three equations, right? Which are those equations? So first of all, equation of, I write in short, multiple regression equation of x1 on x2 and x3. Then second equation, multiple regression equation of x2 on x1 and x3. Then finally, multiple regression equation of x3 on x1 and x2. So these are the three equations which you are going to solve. Okay, we are going to deal with. So these are the three equations. Okay, so case one, you will be given 9 values and the general equation. I have developed a general equation. You have to remember the general equation, and how to use I will also explain. Okay, so be very careful. So general equation is I Ri1 upon sigma 1 x1 minus x1 bar plus. Now I2 sigma 2 into x2 minus x2 bar and Ri3 sigma 3 x3 minus x3 bar is equal to 0. This is that general equation. You have to remember this. You have to remember this. If you could remember this formula, you can derive all the formulas, all the three equations. And in the case 2, there are three equations, so that also you can derive from this. You have to just understand how to use this equation. Okay, so listen carefully. Suppose you want multiple regression equation of x1 on x2 and x3, which is our first multiple regression equation, right? So what you have to do, put I is equals to 1. So what will this equation become, right? So it is 1 upon sigma 1 x1 minus x1 bar plus r12. You have to put I is equals to 1 wherever you are seeing the I. See here, you have to put 1 sigma 2 x2 minus x2 bar plus r13 sigma 3 x3 minus 3 bar is equals to 0. Okay, got it? Below your thumb. If you want x2 on x1 and x3, so what you will do? Put I is equals to 2. So what you get? R21 upon sigma 1 x1. But rest of the things or terms are equal. Okay. Then R22 upon sigma 2. Only the cofactors are changing. If you observe that, only cofactors are changing, nothing else. Okay. So this is 2, 3 upon sigma 3 into x3 minus x3 bar. Okay. And finally, if you want x3 on x1 and x2, so you will have to put I is equals to 3. So only cofactors are changing. The rest of the structure is same in all the equations. Is hand. Just wait a minute. Okay. Okay. You understand it? So what will be the equation now? What will be the third equation? Okay. It is okay. It is R31 upon sigma 1 into x1 minus x1 bar plus R32 upon sigma 2 x2 minus x2 bar plus R33 sigma 3 x3 minus x3 bar is equal to 0. Understand this? All of you understand how to remember? So all these three equations you can remember from this. Got it? Okay. Lawyer comes if you understand. Now I will explain you what is the second case. Okay. I talk about the second case. So here you are given the 6 values, and these are in terms of deviations. Deviations means what? Here you use the difference. Each observation from there are three variables x1, x2, x3, right? So you are subtracting uh, arithmetic mean from each observation from the three variables, right? So x1 is deviation from mean of first variable. Small x2 is deviation of mean from second observation. Then small x3 means deviation of observation from third variable. So here you are using small x1, x2, x3. Okay. So there will be a term called as the deviation from means. You have to understand this. Okay. There will be this term which you have to understand. Deviation from mean. This particular term you have to understand. Deviation from mean. Okay. So this word will be particularly used. 6 values will be there. So which are the 6 values there? So the means will not be given. So it will be standard deviation 1, 2, 3, and R12, R13, and R23. So these are the 6 values will be given in the question. Okay, these are the 3 values. So let's check. In the first case, there is given the 9 values, right? X1, X2, X3, sigma 1, sigma 2, sigma 3, R1, 2, R1. A simple correlation. But here we are given only the 6 values. So arithmetic means are not given. Arithmetic means are not given because there is no need actually. So how to derive the equation? What is the general formula for this? Penta is little bit faint. Okay. So the general equation. So again I will derive it from the previous equation. So I should able to see the previous equation. So this is the previous equation. So you can comparatively study. See, from this what changes I am making, you understand. So I am writing here I'm writing here R I1 upon sigma 1. Now it is x1 instead of this. I'm writing the deviation. Okay, plus R I2 upon sigma 2 into x2 plus R I3 upon sigma 3 into small x3 is equal to 0. So that is the change. So wherever there is x1 minus x2 bar, x1 bar, you have to put x1, x2 minus x2 bar, you have to put small x2. So these are the deviation from arithmetic. You have to replace this one, okay? And all the processes are same. So if you want x1 on small x2 and x3, so you have to, the equation will be r11 upon sigma 1 small x1, then r12 upon sigma 2 x2, then r13 upon sigma 3 small x3 is equal to. But remember that here are capital letters because these are variables, and here are deviations, here are the small letters. Okay, so in the same way. So if you basically see, um, it is sufficient that you should understand this equation. Then you can produce or write both the cases. Okay, did you understand this or not? आपको समझ में आया? मैंने जो आपको हिंट बताया वो हिंट आपको समझ में आया? Blow your thumbs. ओके, तो यहाँ से आप सारे इक्वेशन, जैसे कि हमने यहाँ पे ये सब ड्राइव किया, तो ये इक्वेशन यहाँ से ड्राइव कर सकते हैं। आई, आपको जो भी इक्वेशन चाहिए, x1 चाहिए डिपेंडेंट वेरिएबल, तो आप i इक्वल टू 1 पुट करो, x2 और x1 एंड x2 चाहिए तो i इक्वल टू 2 पुट करो, एंड सो ऑन. ओके, द सेम केस यू हैव टू अप्लाई हियर. So now we are coming to the numerical examples. Now be ready with the calculators. So which case to apply here? Just a revision of what I taught to you. Yes, unmute and tell me. किस तरह का डेटा है यहाँ पे देखो. Yes. Okay. One more concept you have to understand.
9 values.
Yes, yes, yes. 9 values are there, and you have to apply the case one. Okay. Before I go to the numerical examples, so better I will explain you the multiple correlation and uh, partial correlation. Okay. So let's revise that one. Then at a time we can take the numericals. This one is better handling. Are you able to listen my voice clearly? Okay. So first of all, I will explain you multiple correlation and partial correlation. So these were the hints for multiple regression, and now you are able to produce all the three equations very comfortably. Now I will explain you multiple correlation. So in the revision, I will give you number of hints. You have to remember it properly. Okay. So multiple correlation. So what is the formula? Multiple correlation is represented like one capital R I dot JK. Okay. In general, suppose we want multiple correlation of x1 on x2 and x3. So these are not numbers. These are what? These are not numbers. These are what representing some value or variable. So one represents x1, two represents x2, and three represents x3. Remember, okay? And whatever you write before, so this is the dependent variable. This is the dependent variable, and whatever you write after the dot, it is independent variable. Okay, dependent variable and independent variable. Okay. Yes, getting my voice clearly? Yes. Hope you are getting my voice very clearly. So now this is the way of writing the multiple correlation. Okay, so what is the formula? Again, I will write the general formula, right? So you have to observe Ri dot jk. Huh? You understand? You please keep watch how I am writing. Okay, so it is the square root of the entire term. So this one. So I dot jk. So how we write this? So it is R ij square plus R ik square ij then ik R ik square minus 2 times all the products R12, R13, R23. Means if you were to write in general, then you can write here. What you can write? Here you can write here. So R ij, R jk and ik. Okay, upon 1 minus 1 minus now R jk square. Okay, if you not understand this, don't worry. In particular, I will explain you. Suppose you want R1 dot 23. Okay, you want multiple correlation between x1 this one. Okay, so how to get this formula? Now understand. Okay, so it will be in the numerator, it will be R12 square 12 square. Okay, next time plus R13 square minus twice R12 all the three R12 R13 R23. Okay, so you have to subtract the twice of this product. Okay, so no worry. Minus in the denominator you have to write 1 minus R23 square. So this is the way. Similarly, who will tell me R2.13? Yes, who will tell me 2.13? So it is R. Now 2 1 is 1 2. So 1 2 square plus 2 3 square minus twice R12 R13 and R what 2 3. What will be in the denominator? R13 square in this way. Okay. So in this way, you can remember all the three formulas. Okay, got it? Please blow your thumbs. Some points I have to tell you about the multiple correlation coefficients. Multiple correlation coefficients always lie between R dot jk. It always lie between 0 and 1. Remember this point? Okay. So it always lie between 0 and 1. Okay. So this point you have to understand. Because sometimes in the question which is asked, multiple choice or the range of multiple correlation is what? Then I will tell you the partial correlation. Then we will end our lecture. Numericals, you can solve it on your own using the hints given by me. Okay. Now, partial correlation. Partial. So partial correlation are means when you consider the correlation between two and keeping other constant. Okay, now there are three variables x2 x1 x2 x3. So if you study the correlation between two and keep this constant, then you say that partial correlation between x1 x2 keeping x3 constant. So r in general we write like this rij dot k. So here uh, the two subscript you write before the dot are these are studied, and the subscript you write afterwards that is kept constant. In particular, suppose I want to give you example R12.3. So this is the partial correlation. This is partial correlation between x1 and x2. What is the condition? Keeping x3 constant. Keeping x3 constant. Okay. And now I will give you the general formula here also. Okay. So remember the general formula. So very easy again. So it is Ri dot jk. So how you can write this? It is nothing but, now understand how I'm writing. It is Rij. Just a minute. I have written it in the wrong way. So this is Rij dot k. Okay, this is correct one. So in the numerator, I will write Rij minus both the combination. Subtract both the combination Rik and Rjk. So Rik into Rjk. Got it? Now in the denominator, take the square root of the product of the square root of what? 1 minus Rik square. Okay, and into here 1 minus Rjk square. Okay, so I will generalize now. This is a general equation. Now I will give you the particular equation. Okay, I will give you particular equation. So in particular, how can you write? Suppose I want to find out the partial correlation of between x1 and x2 keeping x3 constant. So what will be the formula? So what will be the formula now? So it is R12 minus 13 and 23. R13 into R23 upon 1 minus R13 square into 1 minus R23 square. Understand? Yes or no? Blow your thumbs. Now, okay, those who didn't understand, then let's do this. R13 dot 2. So partial coefficient between x1, x3 and keeping x2 constant. So how you can write? So it is R13 minus R12 into R23. Okay, and denominator 1 minus R12 square into 1 minus R23 square. So in this way you can remember it. Understand? Okay. So now further calculations are very easy. Okay. So if numericals are asked, then you can easily solve it. Okay. So these are the hints which is very valuable to you from the exam point of view. And numericals, I will, if time allowed, then I will give you numericals. Means I will solve numericals. Okay. But now we'll stop here.